this video, we're going to talk about confidence intervals, how to construct them, how to interpret them, and what they're used for. In the video on sampling distributions, we talked about standard deviations for repeated samples. And you can construct the standard deviation using the true proportion. But what happens when we don't know the true proportion? Oftentimes, we don't know the true proportion of a population because it's too difficult to sample the whole population. So instead, we use the sample statistics. And sample statistics are denoted with a hat. So you can see here and in other problems, we notate that sample with a hat over the P. When we use this sample proportion to construct the standard deviation, it's actually just an estimate of the standard deviation. We don't know what the true standard deviation is. So when we estimate the standard deviation of the sampling distribution, we call that a standard error because it's only an estimate of that true standard deviation. It's not the true standard deviation. So notationally, these are two different things. The standard deviation of repeated samples is based on the true proportion of successes and the true proportion of failures over the sample size. The standard error, however, uses the sample proportion of success and the sample proportion of failure to get at the amount of variation. Again, because this is just an estimate of the standard deviation, it's called the standard error. This is what we use when we don't know that true proportion. And that's what we're going to use to construct our confidence intervals. So here I have collected statistics about students from ISU. This survey is done across college campuses throughout the U.S. This is just what the respondents were from ISU. So they surveyed 427 that responded to this question about the forms of birth control that the students use. From the survey, they found that 82.6% of sexually active students use some form of birth control. Again, this is just a sample of the students at ISU. And if it's random, then we can create a confidence interval about where we think the true proportion might fall. So we're going to create a confidence interval assuming the normal model. Remember that with the normal model, 68% of samples should fall within one standard deviation, and 95% of samples should fall within two standard deviations of the true proportion. So we're going to use that idea to construct our confidence interval. We're going to reach up and down exactly two standard deviations from this sample proportion. So for the middle point, we're going to use our sample and we're going to reach up and down two standard deviations. So for the lower bound, we're going to subtract 2 times the standard error, and our standard error is calculated using the sample proportion. This second number is 1 minus the sample proportion, so it's just 1 minus 0.826. And then we divide by our sample size. That gives us the standard error. We're going to use that same standard error for the upper bound. So again, for the upper bound, we use the same starting point, but we reach up 2 standard deviations. So if we reach up and down 2 standard deviations each, that should give us a 95% confidence interval. The numbers we see here that we've calculated are in proportions. If we want to get them in percentages, we just multiply them by 100. So our confidence interval for where the true proportion of sexually active students lies, somewhere between 78.9 and 86.3. That's where we can be 95% confident that the true proportion lies. Again, the rule that allowed us to construct the confidence interval is the 68, 95, 99.7 rule. That says that 68% of all samples have to be within one standard error of that true proportion. 95% of all samples have proportions that are within 2 standard errors, and 99.7% of samples will fall within 3 standard errors of the true proportion. So we're using this rule and the fact that we're repeatedly sampling to create our confidence. So this is the formula that we're following to construct our confidence interval. We're using our sample as that middle point, and then we're reaching up and down some margin of error. This second term is what's called the margin of error. It's some critical z times our standard error, and I talked about earlier how we construct that standard error. It uses our sample. The other thing we need to know is this critical z. We can choose any confidence level that we want, but that's going to affect our critical z value. So if we wanted a confidence level of 68%, then our critical z would be 1. If we want a confidence level of 95%, then our critical z would be 2. But we could choose any level of confidence. We could choose an 80% confidence or a 90% confidence level. And so I'm going to show you some of the confidence levels that are standard across the different disciplines. The critical z value is the z value that you would have to reach up and down to capture the confidence level that you're interested in. So for example, if you want a confidence level of 90%, you would have to reach up and down a z value of 1.645. These values here are the most commonly used critical value z's. They may be worth writing down so that you can reference them quickly for future problems and on the exams. You can see that as we increase our confidence levels, our z-scores increase as well. That means that as we become more confident, our range or our confidence interval is going to get wider. This should make sense because in order to be more confident, you're going to have to increase your range of guesses. And that's what this essentially does, is it increases the range of the confidence interval so that you're capturing more potential outcomes. Thus, there's a trade-off between confidence and certainty and precision in your data. If you want to be more confident, that is, more certain of your range of possible values, then you're going to trade off position. You can't be as accurate in your estimate. The only way to be more accurate is actually to increase your sample size, and we're going to talk about that more when we talk about the margin of error. The last thing I want to talk about is reviewing what the confidence intervals really mean. So every time we generate a sample, we can create a confidence interval. But our confidence intervals are really going to vary from sample to sample. So what does 95% confidence mean if our confidence intervals vary with our samples? We assume that the true proportion does not vary. So here, this green line represents the true proportion. Each time we sample, we can construct a confidence interval. So each of these blue lines represent a confidence interval reaching up and down. You can see that some of them contain the true proportion and some of them don't. Based on how we've constructed these intervals, exactly 95% of them should contain the true proportion, whereas only 5% should not contain the true proportion. And that's based on exactly how we construct it. So let's say, for example, this proportion represents the proportion of heads that you would get if you flipped a coin 10 times. So we can do that. We can sample once and simply flip a coin 10 times and get a confidence interval for where we think that true proportion might be. Now the true proportion is 0.5. We know it in this instance. But we can do this sampling again and again. And let's say we did it 100 times. So we flipped a coin 10 times, 100 for 100 samples. Each sample would have a confidence interval that may or may not contain the true proportion. Based on how we've constructed them, exactly 95 of them should contain the true proportion, and 5 of them won't. Now, in reality, we can't sample 100 times. We generally only sample once because of cost and time constraints. So what we mean by we're 95% confident, what we're saying with that is that we think we got one of the samples that contains the true population. So again, we're using the idea of repeated samples to say that we think our one sample is one that creates a 95% confidence. So we think we got one of the ones that contain the true proportion. So that's how you construct a confidence interval. In the next set of videos, I'm going to go over some problems illustrating how we can construct intervals given some statistics. I'm also going to go over some problems discussing the margin of error, which again is what we're reaching up and down. And I'm going to show you how useful the margin of error can be in determining the sample size a priori so that we can get a confidence level that reaches the range we want.